All right, just to go over again for the precipitate analysis, we would start out by listing the ions that are present in the two solutions that we're combining. So we got the barium ion and the chloride ion from one solution, and then the silver ion and nitrate ion from the second solution. Step 2 is to come up with the possible combinations for these. So we take the cation, barium, from the first one, and the anion from the second one, nitrate, and make barium nitrate, balancing out the charge. And then we take the the corresponding cation and anions, the silver and the chloride, and make silver chloride as the other possible combination. Step 3, we eliminate one of those, if possible, as a precipitate. And there are a couple of examples where both of them form the precipitate. So our 3 ways to try and eliminate would be common knowledge, sodium chloride and nitrates. So those would be ways to eliminate, and we can use that for this one. We'd eliminate the barium nitrate. We also have the option of using eliminating based on whether it was a solution in one of the sets. And finally, the third one is if they're together in another mixture that did not form precipitate, we could eliminate them also. So in this case, the silver chloride ends up being the precipitate. So now we're ready for step number 4. So step number 4, we are going to list all the ions that are present and put them into a balanced equation. So we've got the barium ions, the barium and the nitrate. Oops, sorry, hold on. The chloride ions, the silver ions, and the nitrate ions. So these are the 4 ions that we're starting with as reactants. And then the products, we just determined that the aluminum chloride is a precipitate. Sorry, the silver chloride is a precipitate, so we're going to put that down as a solid. And then we also have the barium ions still floating around in there, as well as the nitrate ions. Now all of the ions are going to be in aqueous form, so we're going to go ahead and put down an AQ as the state of matter for all of the ions. Okay. The other thing we need to do is balance the equation. And here it's a little bit tricky because we have to make sure that we balance the charge as well as the number of atoms of each element. We can balance ions together with this type of reaction. So if we look up at the top, we see that the barium and the chloride are always together in a 2-to-1 ratio. So down here we have to represent that in the equation as well. So if I do 1 barium, I need to have 2 chlorides. What that's going to do then is we're going to need to put a 2 in front of the silver chloride as the precipitate. And then, consequently, we're going to have to put a 2 in front of the silver ion. And looking back up at the top, we see that silver nitrate has to be in a 1-to-1 ratio. So if I have 2 silvers, I have to have 2 nitrates. And then I can fill in the rest, the 1 barium and the 2 nitrates there. And so now I have a balanced equation that represents everything that's in the solution. The last thing we want to do is do what's called the net ionic equation. For the net ionic equation, we're going to eliminate what are called the spectator ions, the ions that didn't change. So if we look at this equation, we see that the barium did not change. It stayed as a 2+. It did not participate in the reaction, nor did the nitrate ions. We're going to cancel those out. And then we're going to rewrite the equation, leaving those spectator ions out. So we have chloride ion in the aqueous state, combining with silver ion in the aqueous state, forming silver chloride solid. In terms of balancing, for the net ionic equation, put down net ionic. For the net ionic equation, we can leave the balancing as is, which is 1 chloride, 1 silver, forming the silver chloride.